One factory, $5 billion, and a deadline America cannot miss because the next century of transportation is already being decided, quietly, relentlessly, on factory floors. Tonight we uncover how electric trucks are being built at industrial scale inside Rivian's manufacturing system. I'm Masood. Welcome to Built in America. This is not a car plant. This is a national experiment. According to U.S. transportation data, pickup trucks represent over 20% of all vehicles sold in America. They haul, they build, they power the economy. Electrifying that segment is not optional. It is strategic. Rivian's main plant sits in Normal, Illinois, a former gasoline-era facility re-engineered for electric production. Over 4 million square feet under one roof. Company filings show billions invested before the first truck reached a customer. Because EV manufacturing reverses the entire build logic. There is no engine block, no transmission tunnel, no exhaust line. Everything begins with the battery. Raw aluminum arrives first, stamped into frames designed to protect battery packs weighing more than 1,000 pounds. Industry data shows the battery alone can represent 40% of an electric truck's total cost. That means structural failure is not cosmetic. It is catastrophic. Robotic arms perform frame welding with tolerance margins tighter than a human hair. Each joint is scanned in real time. If a weld drifts by fractions of a millimeter, the line stops. Because batteries do not forgive errors. Next comes the skateboard platform, motors, inverters, cooling lines, high voltage wiring. According to EV safety standards, these systems carry enough current to kill instantly. So isolation is engineered into every layer. Human technicians step in where robots cannot. Hands route cables, eyes inspect seals. Every worker trained for months before touching live systems. Then the battery pack is installed from below, a single unit, lowered with synchronized lifts, locked into the frame. From this moment forward, the truck is electric forever. Quality control never relaxes. Each vehicle undergoes software diagnostics, water intrusion testing, thermal stress cycles. Industry testing data confirms EV failures most often originate in early assembly. So Rivian hunts defects before customers ever see them. And building this factory was its own risk. Illinois industrial land averages $30,000 to $60,000 per acre. Facility construction exceeded $300 per square foot. Each automated line costs tens of millions. Power demand rivals a small city. Water systems run non-stop. Permits require EPA approval, OSHA certification, fire clearance, and state environmental review. Time to operational launch exceeded 2 years, and federal manufacturing data shows more than half of new auto plants never reach profitability. Why try? Because America depends on who controls vehicle manufacturing next. Gasoline built the 20th century, electric decides the 21st, and this factory is only the beginning, because once the line starts moving, it never truly stops. The most dangerous part of an electric truck is invisible. No flames, no noise, no warning, just current. Inside Rivian's plant, this is where the vehicle becomes lethal if built wrong, because once the battery goes in, there is no undo. According to federal safety data, modern electric trucks carry up to 800 volts, enough energy to kill instantly, enough heat to ignite metal, so this stage is treated like a containment zone. Battery modules arrive sealed, each one weighing over 1,000 pounds. Industry data confirms the battery can represent up to 40% of total vehicle cost. One crack, one seal failure. The entire truck is scrap. Installation happens from below. The frame is lifted. The battery is raised by synchronized robotic platforms. Alignment tolerance stays under 2 millimeters. If it misses, the line stops. Cooling lines connect next. Liquid thermal systems designed to keep cells within narrow temperature bands. Too hot, cells degrade. Too cold, range collapses. According to EV engineering studies, temperature imbalance is the leading cause of early battery failure. So Rivian builds redundancy, multiple sensors, independent shutoffs, software checks running before power is ever applied. Only then do humans approach. Workers wear insulated gloves. Tools are voltage rated. Every movement trained and rehearsed. High voltage cables are routed by hand. Orange lines, clear warnings. One mistake here can shut the factory down. Next comes the brain. Software flashes begin. Each truck receives millions of lines of code. Power management, torque control, thermal logic. Industry data shows most EV recalls originate in software, not hardware. So, Rivian tests repeatedly, cold starts, hot cycles, fault simulations. If the system disagrees with itself, the truck never moves forward. This is where electric manufacturing separates winners from failures, and building this capability nearly kills new factories. Battery-safe facilities require reinforced floors, special fire suppression, dedicated emergency systems. Construction costs rise fast. Electrical infrastructure alone can exceed tens of millions. Permits multiply. EPA, OSHA, state fire authorities. Time adds up. Money evaporates. Federal manufacturing records show more than half of EV startups fail before scaling battery production, because this stage cannot be rushed and cannot be cheap. But if it works, stream survives because from this moment on, the truck is alive, silent, charged, waiting, and the factory keeps moving. At this stage, the truck already has power, now it needs control. Because an electric vehicle is not just metal and batteries, it is software on wheels. Tonight we uncover the middle of Rivian's factory, where machines, humans, and code collide. After battery integration, the chassis moves into general assembly. This is where the vehicle starts to look familiar. Suspension systems, drive units, steering racks, braking hardware. But unlike gasoline trucks, nothing here operates independently. Everything is networked. According to automotive software data, modern EVs can contain over 100 million lines of code. That code begins loading before the truck can even roll. Robotic systems install wiring harnesses that resemble nervous systems, miles of cable, high voltage, low voltage, data lines. Each route is mapped digitally. If one connector is misplaced, diagnostics will catch it within seconds, because software is always watching. Human workers dominate this section. Robots cannot feel resistance. Humans can. Workers install interiors. Dashboards, displays, seats, every action logged, torque measured, sequence verified, time stamped. Industry manufacturing records show mixed human-robot lines reduce defect rates by more than 30% when properly trained. But training is expensive. New Rivian workers spend months in simulation environments before touching live vehicles, because one mistake can brick a truck permanently. Now software activation begins. The truck wakes up for the first time. Screens light, modules handshake, sensors calibrate, cameras, radar, ultrasonic sensors. According to ADAS calibration standards, even a millimeter of misalignment can degrade safety systems. So calibration bays look like science labs. Targets placed, lasers aligned, software adjusted. Only when every system agrees does the truck move forward. Quality control intensifies. Every vehicle runs through dynamic tests: steering response, brake pressure, motor synchronization. Software logs thousands of data points in minutes. Any anomaly triggers investigation, and building this section of the plant is not cheap. Assembly land requirements mirror automotive hubs like Illinois, Georgia, and Texas. Industrial land averages $30,000 to $70,000 per acre. Interior assembly space costs roughly $250 to $300 per square foot. Automation software licensing alone can exceed tens of millions annually. Power demand spikes. Data infrastructure expands. Cybersecurity becomes critical. Permits multiply. OSHA for worker safety. State electrical authorities. Fire suppression approvals. Environmental compliance. Time to stabilize production in this phase can exceed 12 months. And industry data shows this is where most EV startups fail. Software delays, integration bugs, training gaps. The factory does not forgive instability, but when it works, the line flows, quiet, precise, relentless. Because this is where electric trucks stop being experiments and start becoming products America expects to work. At this stage, the truck already looks finished, painted, wired, powered, but inside Rivian's factory, this is where most vehicles fail. Because an electric truck is not mechanical first. It is digital. Tonight, we uncover the systems inside Rivian's plant that decide whether a truck ships or disappears. Once final assembly ends, the vehicle enters software activation. According to automotive engineering data, modern electric trucks contain over 100 million lines of code, more than a commercial jet. Every control unit must wake up in the correct order: battery management, motor control, thermal regulation, braking, suspension, driver assistance. One corrupted signal can disable the entire platform. So Rivian runs layered diagnostics, hardline tests, wireless checks, redundant validation loops. If a module fails, the truck does not move forward. It moves backward. Next comes dynamic calibration. Steering sensors, ride height, torque vectoring. Industry data shows electric drivetrains respond instantly, leaving no margin for misalignment. So calibration occurs at microscopic resolution. Then stress testing begins. Each truck enters a controlled test lane. Acceleration, emergency braking, load simulation. Battery temperature is monitored second by second. According to EV reliability studies, early thermal instability predicts long-term failure. So, unstable vehicles are removed immediately. Water testing follows. High-pressure spray systems simulate rainstorms, floods, and road spray. Any moisture intrusion into high-voltage zones is an automatic reject. Then, human inspection returns. Trained technicians inspect seams, panel gaps, interior wiring, seal compression. No shortcuts, because electric failures are silent until they are catastrophic. Only after passing every checkpoint does the truck earn shipment approval. And building a facility capable of this level of validation is brutal. Best states for EV manufacturing include Illinois, Georgia, and Texas. Industrial land averages $30,000 to $70,000 per acre. Building costs exceed $300 per square foot. Testing equipment alone can exceed $50 million per plant. Power demand rivals small cities. Water systems run continuously. Permits require EPA clearance, OSHA approval, state environmental review, and fire authority sign-off. Average time to operational readiness exceeds 30 months, and federal manufacturing data confirms more than half of new vehicle factories fail to reach sustained profitability. Because software defects do not forgive optimism, this is why most startups never survive scale, but for those that do, the factory becomes a gatekeeper, deciding which machines America is willing to trust at highway speed. And the next phase is where those trucks finally leave the building. The truck is finished, but the risk is not, because the most dangerous moment in any factory is when the product leaves the building. Tonight we uncover the final system inside Rivian's electric truck plant, the stage where manufacturing ends and national exposure begins. Once a truck clears testing, it enters controlled storage. Batteries are kept at regulated charge levels. Software locks are applied. Every vehicle digitally tracked. According to automotive logistics data, electric vehicles degrade fastest when stored incorrectly. So timing matters. Ship too early or too late, and value disappears. Outbound logistics is precision choreography. Rail, truck, regional hubs. Each route approved for battery transport under federal hazardous material rules. One paperwork failure can halt hundreds of vehicles, and once trucks reach dealers, liability transfers instantly. According to U.S. consumer safety law, the manufacturer remains responsible for systemic defects. One software flaw, one thermal oversight, can trigger recalls costing hundreds of millions. This is why Rivian monitors trucks even after delivery. Telemetry feeds back performance data, battery health, charging behavior, environmental stress. Factories no longer stop at the loading dock. They follow the product for years, and building a plant capable of sustaining that system is brutal. Best states for EV logistics remain Illinois, Texas, and Georgia. Industrial land ranges from $30,000 to $80,000 per acre. Facility construction exceeds $300 per square foot. Logistics infrastructure adds tens of millions more. Daily power demand rivals small cities. Battery-safe storage requires redundant fire suppression. Permits include EPA, OSHA, DOT transport compliance, state zoning, and fire authority clearance. Average time to full operational stability exceeds 3 years, and industry failure rates remain unforgiving. Federal manufacturing data shows more than 50% of new EV facilities fail to scale profitably. Why? Supply volatility, policy shifts, battery cost swings, warranty exposure. One bad year can erase the future, which is why surviving plants become something else entirely. They become national manufacturing anchors, because America does not just buy vehicles, it depends on them for work, for emergency response, for supply chains that never sleep. And tonight, as trucks leave this building, they disappear into the country, driven, loaded, trusted, while inside the factory, the line resets, the next battery arrives, and the next truck begins forming, because the system never stops, and America never waits.